Drawers are designed to fight gravity. That is, to support weight, a force directed straight down. But the case that encloses and supports the drawers encounters forces in several directions. That's the reason case construction and weld joint design and total weld count are so important. When it comes to the total number of welds, you can count on the market leader, Snap-on. But sheer numbers don't tell the whole story. Proper weld joint design is just as important. Take a look at these samples. Both high-quality welds that you've come to expect from Snap-on. In our tests, it took up to 10 times the force to tear this one apart. Weld placement needs to be designed to take advantage of that strength. Guess which one is integrated into the top panel of a Snap-on unit? Our top panel has full perimeter support, resting front, back, and sides on a return flange, our standing seam design. When a top chest or work surface is loaded, our perimeter welds are loaded in their strongest condition. Exceptional strength is designed in. Here's how Mack, Matco, Craftsman, and Cornwell all attach their top work surfaces. What's called a double exposed edge. Two metal sheets lined up and spot welded together. Now, you gotta wonder why the other guys would settle for a design like that. My guess is it's cheap and it's easy. As strong as our perimeter is, the middle has to stand up too. We rely on a pair of strategically located Z-stiffeners that are over 2 inches tall, running side to side. Matco uses these cute 3/4 inch hat channels that are comparatively weaker than our Z-stiffener. Mack uses hat channels too. They're big, thick channels that appear impressive, but uh-oh, look at this. For some reason, they stop well short of the back wall. Cornwell and Craftsman use nearly identical designs to support their top. They call it a roll cage. Understanding the weakness of this design is child's play. Weight applied to the top is transferred down. Okay, you see their problem. Remember this illustration? It shows the forces involved in racking. That's the tendency for a parallelogram to collapse. Unfortunately, that parallelogram, their roll cage, supports their top and all the weight of the drawers. Now, Matco tries to fight the racking forces by welding in this big center shelf that doesn't store any tools. But it seems that they misunderstand the physics of it. Snap-on relies on scores of well-designed joints and well-placed welds to transfer forces through full-height inside panels, reinforced with Z-stiffeners along multiple flanges through various stiffeners and supports. The single most important support being corner gusses. They supply both strength and flexibility and allow our unit to resist failure due to racking forces. So let's frame up the challenge with a simple test on a frame straightener. If our engineers have gotten it right, we should be able to apply measured force. Release it, and the box should bounce back. First, we tested the Snap-on unit. The Snap-on unit deflected but didn't deform. That's real strength. Now, using the same rig, we applied similar forces to the competition. First, the Mack. Mack exhibited some racking, and the side started to crumple. Now Matco. Matco had more obvious racking and twisting. Also notice how the side severely deformed. Cornwell and Craftsman couldn't even take the same force. How about Cornwell? Cornwell showed severe racking, twisting, and the bottom caster skid support tore and broke loose. Finally, CRAFTSMAN. No surprise, CRAFTSMAN showed similar failures to CORNWELL. Plus, the sidewall deformed. Ooh, kind of reminds me of the old car crusher. Chalk one up for the Snap-on engineers.